Okay, so let's continue. As far as fine aggregates or sand is concerned, and we already defined it before, now we're going to proceed to the grading analysis for your fine aggregates. Why is it that your grading analysis for fine aggregate is very important? First, yung sample na sinabit mo as per minimum testing requirements, dapat masatisfy niya yung condition ni ni fine aggregates or yung item 311.1 natin. And also, number 2 purpose of this one, why we need to analyze this fine aggregate is simply because of this fineness modulus. Okay? So, dapat din natin malaman yung fineness modulus of these fine aggregates. Anyway, fineness modulus, this formula is given as your percent retained of sieve 3/8 inch plus sieve number 4 plus number 8 plus sieve number 16 plus sieve number 30 plus sieve number 50 plus sieve number 100 divided by 100. Okay? So, sir, bakit natin kailangan kunin itong fineness modulus? Because from here, we can identify whether your fineness modulus is higher or lesser. So, kasi sabi niya, always take note that the higher the fineness modulus, the coarser the aggregate. Okay? That is why we need to determine your fineness modulus because of this condition that the higher the fineness modulus, the coarser the aggregate. Otherwise, the lesser the fineness modulus, the finer the aggregate. Okay? So, ito yung importance ng fineness modulus natin. Again, just to review the formula for your fineness modulus, it states here that your percent fineness modulus is equal to percent retained. Always take note, guys, percent retained dyan. Hindi siya percent passing. So, word percent retained of what? Sieves. Set of sieves which are composed of 3/8 inch plus sieve number 4 plus sieve number 8 plus sieve number 16 plus sieve number 30 plus sieve number 50 and plus sieve number 100. Okay, that would be your fineness modulus. And then, now, next, let's proceed to your coarse aggregate. What does it mean by coarse aggregate? Kung sabi natin kanina, ang fine aggregate, that is your sand, wherein consists of natural sand. Dapat yun. How about your coarse aggregate? This shall consist of crushed stone naman. Crushed stone, gravel, and so on. So you go on as you want to read your DPWH Blue Book. As far as coarse aggregate is concerned, you can read there that you may read there na malalaman mong coarse aggregate shall consist of crushed stone and gravel. Anyway, if your fine aggregates have a grading analysis, meron din itong requirement for your coarse aggregate. Meron din tayong grading requirement for item 311 or which is your PCCP, and then item 405 which is your structural concrete. Okay? So, kung meron grading analysis fine aggregates, meron din tayong grading requirement for item 311 and item 405 for our coarse aggregate. Anyway, I gave it to you through your module kung saan nyo mababasa yung grading requirement for your coarse aggregate. Okay? So, this is another composition of your concrete. Next is yung water. Water is actually item 714. Okay? Item 714 siya. Wherein, your water, as this one is your key ingredient, serve as your key ingredient through the composition of your concrete, or ito yung pinaka main ingredient natin. Ingredient. And lastly, to use your water, make it sure that your water is clean. So in mixing your concrete, dapat clean dapat yung tubig na gagamitin natin. And then also free from oil, salt, and acid, etc. Anyway, some of you will ask, sir, how about yung tubig ulan? Pwede ba natin gamitin yun? I'm not against dun sa tubig ulan na gagamitin. But as per DPWH's concern, or yung standard specification is concerned, sabi niya kasi dito, free from oil, salt, and acid. What if that rain is as an acid rain? May tendency na maging factor yun dun sa item 714 natin, which is water. Kasi sabi niya dapat clean, or hanggat maaari yung tubig na gagamitin na iinom. So, yung acid rain, yun nga, sasabi ko, hindi ako against doon. Kung gusto mong gamitin to, bago mo siya gamitin, make it sure na meet niya muna yung specific requirement ni water or your item 714. So, may specific requirement siya para malaman natin kung pwedeng gamitin yung tubig ulan and so on. Okay? And then lastly, the composition of your concrete is yung admixture. So, ano ba itong admixture nito? Inuulit ko, admixtures, these are the ingredients that are added to the mixture immediately. Okay? Biglaan tong ina-add or during mixing. Okay, what is the purpose of this one admixture? Ang admixture natin kasi, there are many types of admixture, whether that is accelerating admixture, that is retarding admixture, and so on. Ang admixtures kasi natin, ito yung nagpapatibay mismo dun sa konkreto. Dinadagdagan nila yung parang strength. Parang nagiging factor ito para mas ma-strengthen pa yung concrete natin. And then yung admixture natin, that is always a chemical siya na dinadagdag dun sa composition of your concrete. So, other than water, cement, and aggregates, itong admixture, optional to. Lagi niyong tandaan that admixtures, optional lang siyang ginagamit. Hindi ito mandated. So, optional siya. Okay? So, that is the composition of your concrete. Now, let's going to apply this position of concrete in actual construction. Like for example, punta tayo sa actual construction. And I'm going to teach you what are the minimum testing requirements in actual construction, especially in horizontal construction and vertical construction. Anyway, let me proceed first to your item 311. Okay? So, item 311. Actual construction tayo. Again, item 311 is Portland cement, concrete, pavement. Oh, yan. Portland cement, concrete pavement. So actually, this item is only used for your road construction. Okay, sa road construction to. And as you can see, for item 311, Portland cement, concrete pavement. Siyempre, dun sa pavement natin, expect there is a cement. And then the minimum requirement for your cement, kapag sa site, example sa site, nag-deliver sila ngayon ng around 2,000 bags of cement. So, meron silang delivery of 2,000 bags of cement. Take note, itong 2,000 bags of cement na dineliver sa site, prior to this, you must get a sample of at least 10 kg. Yan ang minimum requirement na ang 2,000 bags of cement, kuha kang 10 kilograms sample nito. And then after which, you need to test this 10 kilogram prior to this number of cements. Okay? So, 2,000 bags of cement, ang minimum requirement na itetest mo for your sample is almost 10 kilogram. Ito yung gagamitin natin yung VCAT apparatus or Gilmore needle sa laboratory natin. So, itetest mo mismo yung semento mo. Okay, kung na-meet na yung standard specifications ng cement. And then next, ang napapansin pa natin sa item 311, meron tayong nakikita na bakal. Okay, yung RSB or reinforcing steel bars. Anyway, bakit kailangan ng reinforcing steel bars? Mamaya, i-explain ko kung bakit kailangan ito. Okay? Like for example, sa construction site, nag-deliver sila ng almost 10,000 kilograms. 10,000 kilograms na reinforcing steel bars. Ang minimum requirement na kailangan mong patest dyan is almost 1 meter. 1 meter ang ipapatest mo for your reinforcing steel bar, 1 meter RSB. Why? Kailangan natin malalaman yung tension nito, tensile stress, bending stress, and yung chemical analysis na mismong ginamit dun sa bakal. Okay? Kasi may grade ito, may grade 230, may grade 420, 415, and so on. Anyway, sa reinforced concrete, yung mas malalaman yung composition ng reinforcing steel bars. Okay? So, yan. Anyway, let's proceed. Prior to the practice of your road construction, okay? Kung ito yung center line natin, sabi ko nga, yung center line natin, and then sa top portion, we have your, ano yun na meron dito, item 311. Item 311 mo is your Portland cement, concrete, pavement, and sa below your item 311, it's either this one is item 200 or item 201, which is your aggregate, sub-base, or base course. Okay? And then, for your item 104 naman, yun nasa baba ni item 200. This one is your embankment. Okay. Review lang natin. The minimum requirement for the field density test dito, compaction dapat dito is, sa embankment is 95%. Yes? And for aggregate base course naman, ang minimum FDT nito is 100%. Okay, yan ang FDT nung dalawa. For embankment, 95%. For aggregate base course is 100%. Review lang natin yan. Anyway, so sir, this is my question. Sir, paano ako mag-proceed sa item 311 ko? Simple lang. Make it sure that your item 200 and item 201 dapat na-meet niya yung field density test or your degree of compaction mo na 100% or greater. So, kapag na-meet niya na yan, this one, ready for pouring ka na. Pupunta ka na ng item 311, which is your Portland cement and concrete pavement. Considering that this item 200 and item 201 nakapasa ngayon, so we will now proceed to your item 311, this one. Okay? So, this one is your center line. And sabihin natin, this one is your first lane and second lane. So, dalawang linya natin. So, napansin nyo, before we proceed to reinforcing steel bars, punta tayo ngayon sa pouring. May requirement kasi dyan. And considering that ang bubuhusan natin is this first lane. Itong linya ang una natin bubuhusan. This portion. From this portion up to this portion. And let's say, ang length niya is 120 meters. And then the road width of your road is 5 meters. Again, this one is double lane. And take note, sa pagbubuhos ng kalsada, single lane muna yan. Kasi later on, maglalagay tayo ng mga bakal yan. Yeah, that's why I will not consider that this isang lane muna yung consider natin. This lane. This portion of lane. Ito yung consider lang natin. Okay? Yan yung consider natin. And the half of this, ang half ng 5.0 meters is 2.5 meters. Diba? So, ang point ko dito, may minimum requirement kasi daw, ang volume of concrete kapag 75 cubic meter na or 75 m cube na ang naibuhos, ang minimum requirement kasi dito, minimum requirement, meron tayong isang set na 3 beam samples, and then meron tayong isang set din na 3 compressive or cylindrical sample for compressive to, for cylinder samples. Okay, and then another requirement dyan yung slump test. Mamaya i-explain natin sa slump test. Proceed muna tayo dito sa volume of concrete. Example lang. Sabi ko nga, kung ito yung propose, if this one would be the proposed pavement for pouring, ito yung station na kailangan natin bubuhusan, and napasa nyo na lahat yung aggregate, napasa nyo yung field density ng aggregate base course or it's either aggregate sa base course or base course. Now we're going to proceed for your volume of concrete. Ngayon, ang mangyayari kasi dyan, lalagyan mo ng steel forms. May forms yan, may steel forms din dyan. And take note na nilalagyan natin ng steel forms ito para maging uniform yung pagkalagay doon sa konkreto natin, mixing of concrete. And itong 75 cubic meter guys, ito na. Example, darating na si transit mixer. Ang transit mixer kasi natin is ideal. Ang laman ng transit mixer is 5 cubic meter, 7.5 cubic meter, may 8, may 9 din, may 10 cubic meter. Sabihin natin, itong mga transit mixer na ngayon na ito, binuhusan nila ngayon ito hanggang dyan. Okay? Nakita nyo, binuhusan nila ngayon. And then next, one thing more, you need to calculate first kung naka 75 cubic meter ka na. Example lang, ang binuhusan na ni transit mixer sa maghapon is at a length of 120 meters and at a road width of 2.5 meters. Ngayon, ano bang kulang dyan para maging volume? The thickness. Let's say, ang thickness ngayon nung konkreto natin is 0.25. So, kukunin natin yung volume yan. The volume of this one is length times width times thickness. Kasi yan yung magiging volume nung binuhusan natin. So, ang volume ko ngayon, 120 times width mo is 2.5 times a thickness of, this one is your thickness, 0.25 meters. If we're going to multiply this 3, ang volume ko yung ngayon dyan is 75 cubic meter. Tama? So, exacto. So, meaning to say, itong volume mo dito na 75 cubic meter, the minimum requirement na dapat mong gawin, magawa ka ng isang set composed of 3 beam samples, isang set composed of 3 cylindrical samples, and isang set ng slump test. Okay? So, now, let's start first with your 3 beam samples and 3 cylinder samples. So ngayon, ang magkakandak nito, it's either yung tauhan mo na, yung laborer mo na, or ikaw mismo na material engineer, kasi napaka-importante ito. So ngayon, itong isang set ng 3 beams of sample, kukuha tayo mismo dito sa sample natin, yun sa konkreto natin dito mismo. And then, from that, meron kasi tayong dimensions for our beam sample. Ulit ko nga, meron tayong dimension na 6 by 6 by 21. Okay? So, let's proceed first to your beam sample. So, sa beam sample kasi natin, beam sample. Ang beam sample natin, ito binigay ko yata sa module nyo to. Meron tayong dimension dyan na, okay? Meron tayong dimension na 6 by 6 by 21 inches. Ayan. 6 inches by 6 by 21 inches. So, ang procedure kasi natin sa pag-determine ng or paggawa ng beam sample natin, meron tayong molde na dimension mo is 6 by 6 by 21. Anyway, ang pag-conduct kasi dito, meron tayong tinatawag na 2 layers. So, gagawin mo, sa 2 layers na yan, meron ka dapat 63 blows. Ang ibig sabihin ng 63 blows, yan yung parang itatamp mo siya, bibilang ka hanggang 63 blows. 1, 2, 3 hanggang 63. Let's say, for example, 2 layers siya, no? Ang gagawin mo muna, ang lalagyan mo hanggang sa gitna. So, yung beam sample mo. Let's say, this one is your beam mold. Yan yung beam mold mo. Ang una mong gagawin, lalagyan mo ngayon siya ng concrete dito. Yan. And then after that, pagkalagay mo ng concrete, i-blows mo ngayon. How many times? 63 blows. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, hanggang 63. And then after nun, second layer na, maglalagay ka ng another layer dito. Another layer. This one is your another layer. Another 63 blows. Kaya, 2 layer sa beam mold is equal to 63 blows. 63 na. So, every layer natin, meron tayong 63 blows. So, 2 layer dapat, meron kang sa isang layer, 63 blows. So, sir, paano nakuha yan? Simple lang. Ang dimension kasi natin sa beam mold natin is what? Ang beam mold dimension mo is beam mold dimension. Beam mold dimension. Meron tayong area. Ang length mo is 21 inches, right? And then ang width mo ngayon is 6 inches times 6 inches. So, 21 times 6 is around 126 square meter. Tama? Sabi ko nga, ilang layer ang applicable? Dapat 2. So, divided by 2, this one is equal to 63 blows. So, ito yun. Ayan. So, meaning to say, kapag na-perform mo na to, kuha ka ulit ng another mold kasi yun nga isang set, tatlong beam mold sample dapat. Okay? So, what if, sir, ang dimension ng beam mold ko is 6 by 6 by 20. Kunwari lang. O, example natin, ang beam mold mo, dimension mo ngayon is 6 by 6 by 20. Ilang layers or ilang blows naman yung gagamitin ko. Ganun lang. Kunin mo yung beam dimension, area is equal to 20, length mo is 20 times 6. So, area is equal to 120. Ilang layers ang requirement? 2 layers divided by 2. So, ilang blows? 60 blows. So, every layer dito, dapat mag-tank ka ng 60 blows. Ang blows kasi dito, yun yung parang tinatamp mo siya. So, meaning to say, ang blows mo dyan, first layer mo dyan, lalagyan mo ng concrete, meron kang 60 blows. Sa second layer naman, meron kang ulit 60 blows. Pero kalimitan, ang dimension ng beam sample natin is 6 by 6 by 21. Kaya, in every layer, 63 blows, a total of 2. So, 2 layer. Compare natin sa tawag dito, cylinder. Sa cylinder kasi natin, cylindrical sample, okay? Yan ang magiging cylindrical sample kasi natin. So, in our cylindrical sample naman, we have at least 3 layers dito. 3 layers ang gagamitin natin dito. So, kunwari, this one is your mold sa cylindrical sample mo. Meron kang 3 layers at 25 blows. 3 layers, 25 blows. Yan. Or meaning to say, 3 layers. Sa 3 layers mo yan, meron kang 25 blows per layer. Okay? So, sabihin natin, ito yung cylindrical sample mo. Ang dimension nito is 6 inches by 12 inches. Ayan, 6 inches by 12 inches. So, ang una mong gagawin, divide mo lang ito ng 3 kasi 3 layers to eh. So, divided by 3. So, let's say yan na. So, yung 1/3 ng 12, 1/3 ng 12, 1/3 ng 12. So, L over 3, L over 3, L over 3. So, meaning to say, kapag maglagay ako dito, maglagay ako dyan ng concrete ko, dapat itatamp ko siya ng 25 blows. Okay? Compare dun sa beam sample, dapat 63 blows. Tama? Dito naman, mean 25 mo siyang parang itatamp. 25 blows. And then, pagkatapos naman ng 25 blows, another na naman. Another blows na naman tayo dito. Lagay ka na naman dyan. Another 25 blows. And then, after matapos ng second layer, punta ka ng third layer, another 25 blows. Okay. So, mapansin nyo rin na dun sa sinend ko, pwede nyo siyang ma-analyze doon. So, another 25 blows. So, lagi nyo natandaan na. So, sa cylindrical sample natin, 3 layers. Compared sa beam sample nyo, 2 layers lang siya at 63 blows. Ito naman, every layer, 25 blows. Okay? So, sulat ko lang, every layer, 63 blows or 63 blows per layer for your beam sample. 63 blows for layers for your beam sample. And for your cylindrical sample naman, 25 blows per layer. Alright? So now, okay? So we are done. Ang importance kasi nito, itong beam sample natin, beam sample and cylindrical sample natin, itetest natin ito. Okay? We're going to test this specimen. So dapat ma-meet niya yung minimum requirement niya for our beam sample. Okay? Balik tayo sa beam sample. Kunwari, ito yung magiging beam sample na natin. Tinanggal mo na muna sa molde, and then prior sa testing, after 14 days, papatest mo na siya. Meron kasing requirement. Okay? Ang beam sample mo, ang testing dito is to determine the flexural strength. Flexural strength. Okay, yan. Ang flexural strength kasi ito, ang beam sample mo kasi, itong sample mo dito, malalaman natin yung flexural strength. Meaning to say, dapat ang flexural strength mo dito not less than 3.8 megapascal, or this is around 550 psi when tested when tested by the third point method. Okay, and then your flexural strength for your beam sample naman 4.5 megapascal or 650 psi when tested by the midpoint method. Tested at how many days? 14 days. Ganun din sa tested at 14 days. Okay. 14 days. Yan. So, that is our requirement. So, ang beam sample mo, yun yung purpose na bakit mo ginawa yung beam sample mo. Kasi later on, yung beam sample mo dun sa molde, magiging ito na. Papatest natin to at tested at 14 days. Ngayon, dapat ang beam sample mo dito na yung mixture mo dito sa station mo na kung saan yung binuhusan mo, dapat ma-meet niya yung requirement niya kapag pinatest ko na. So, ang gagamitin na testing machine dito is yung universal testing machine. Meaning to say, ang flexural strength niya dapat kapag ipapatest ko tong sample ko dito, dapat not less than 3.8 megapascal or 550 psi tested by third point method. So, meaning, ibig sabihin ng third point method, ganito lang third point method. Okay? So, ito kasi yung third point, yan ang third point natin. Third point natin, ito yung mga third point natin. Point. And then, compare mo dito, ito yung midpoint natin, o middle third. Midpoint or middle third yan. Ayan. Kapag ang flexural strength mo is prior to the testing of the third point method, dapat ang result ng beam sample mo is 3.8 megapascal. So, pag above 3.8 megapascal, meaning to say, yung konkreto na binuhos mo dito, malakas at na-meet niya yung specific requirement. Okay? Kasi may tendency kapag hindi niya na-meet yung specific requirement na 3.8 megapascal, may tendency na ito mahina. And then, may tendency na i-remove and replace, babakbakin prior to the expense of the contractor. Lagi nyo tandaan. Kaya, napaka-importante yung quality sa trabaho. Hindi bara-bara. Kaya, ang buhay ng pavement na to ay nakasalalay sa mga sample natin. Okay? So, next. Yung flexural strength dapat naman nito kapag ipatest mo itong beam sample mo, kapag when tested by midpoint method, kapag pinatest mo midpoint method, dapat ang testing mo is more than or equal to 4.5 megapascal. So, meaning to say, kapag mababa dito, yung flexural strength mo dito sa sample mo yan, may tendency na babagsak or ma-remove or replace yung binuhusan mo dito. Okay? Pero pag greater naman dyan, proceed ka na. Meaning to say, maganda yung mixture ng concrete mo. Hindi ka na sobrahan ng tubig, and so on. Okay? Yun yung importance niya. So, after that, lagi nyo rin tandaan na ang beam sample is for flexural strength and yung cylindrical sample is for compressive strength. Yun yung determine natin. Okay? So, pause ko muna. Isasave ko lang yung video. And then, balik ako sa topic natin or yung lecture. Thank you.